All right, so if you thought Wi-Fi 6E was the last word in wireless, well, think again. There's a new standard rolling out, and honestly, it's not just an upgrade. We're talking about a leap so big it could totally change how we think about wireless. So let's dive in and break down the next generation, Wi-Fi 7.
Now, everything we're going to talk about today comes straight from the experts, the folks really deep in the weeds of wireless engineering. This is actually part 13 of a super detailed 20-part series on Wi-Fi and Bluetooth standards. It's from a report by RFI Detectives, who are part of Virtualization Options LLC. And today, we're pulling out everything they have to say about Wi-Fi 7.
Okay, so first things first, why do we even need another Wi-Fi standard? I mean, isn't Wi-Fi 6E good enough? Well, the short answer is not really. Our digital appetite is just getting bigger and bigger, and it's starting to push our current networks to the brink. And it's not just about more phones or laptops. The apps we're using now demand insane throughput, and this is the key part, deterministic low latency. And what that really means is it's not just about being fast. It's about being predictably, reliably fast every single time.
And we're talking about some serious demands here, way beyond just faster downloads. Think about something like high-res XR, virtual and augmented reality. The tiniest bit of lag and you're going to feel sick. It completely breaks the experience. Or what about industrial automation? We're talking robots on a factory floor. A delay of just a few milliseconds, that could shut down the entire production line. For stuff like this, that predictable, rock-solid low latency is actually way more important than just raw speed. And so, this is where the industry's answer comes in. Wi-Fi 7. Now, its official technical name is IEEE 802.11be. And just a quick note, we're going to say that as 802.11be, just so nobody confuses it with that ancient 802.11b standard from back in the day. Right, so this is the tech that's been built from the ground up to tackle all those crazy new demands we just talked about. And to give you a sense of just how big a deal this is, the report we're drawing from calls it, and I'm quoting here, the most ambitious revision to the Wi-Fi PHY and MAC layers since MIMO was introduced. Now, for those of you who remember, MIMO, that's multiple input, multiple output, was a complete game changer for Wi-Fi. It's what gave us all this speed. So to put Wi-Fi 7 on that same level, yeah, that tells you this isn't just an incremental update, this is a fundamental redesign.
And get this isn't some far-off future tech. No, this is happening right now. The first part of the standard just got published in May 2024. We've actually had certified Wi-Fi 7 products shipping since the beginning of the year. And the whole thing, the full standard, is on track to be completely ratified by the end of 2024. It's here.
All right, so how exactly does Wi-Fi 7 pull all of this off? What's the secret sauce? Well, this is where we get into the really cool engineering. Let's break down the core tech that's making all of this incredible performance possible. And we'll start with the stuff that just makes it go crazy fast.
Okay, so the first ingredient for more speed is pretty simple actually. Make the data highway wider. A lot wider. Wi-Fi 7 introduces these massive 320 MHz channels, and they only exist in that new, super clean 6 GHz band. The analogy is perfect. It's like we just doubled the number of lanes on the freeway. You can just push way more data through all at once. Yeah, just to really let that number sink in, 320 MHz. That is double the absolute maximum channel width we had with Wi-Fi 6E, which was 160. And again, this is only possible because of that wide-open, uncongested 6 GHz spectrum, and makes that piece of the airwaves more critical than ever. This one feature alone is a huge part of how Wi-Fi 7 hits its goal of extreme high throughput.
All right, so we've made the highway wider. The next trick is to pack the trucks more efficiently. This is where a feature called 4096 QAM comes in. It's a much denser way of encoding data onto the radio wave. So with Wi-Fi 6, we could pack 10 bits of data into each little packet. With Wi-Fi 7, we're cramming in 12 bits. It's literally like figuring out how to fit more packages into the exact same delivery truck.
So what does that mean in the real world? It means a straight-up 20% boost in data rate compared to Wi-Fi 6. And when you combine that with the double channel width we just talked about, you can see how these gains start to stack up and get massive really fast. Now, to be fair, you do need a really good, clean signal for this to work, so you'll get the biggest benefit when you're closer to the access point. But when you are, it's a huge boost.
But you know what? All that raw speed, that's only half the story. The really revolutionary part of Wi-Fi 7, what really sets it apart, isn't just brute force. It's about making the entire network smarter, way more intelligent and efficient, especially out in the real world where you've always got interference and other networks to deal with.
And here's a perfect example of that intelligence.
It's a feature with a great name, preamble puncturing. So picture this. In the past, if you had a nice big channel, but some tiny little part of it had interference, maybe from an old device, well, too bad. The whole channel was useless. You couldn't use any of it. But now, with Wi-Fi 7, the access point can just look at that big 320 megahertz channel, see that little bit of interference, and basically just punch a hole around it. It carves out the bad part and uses all the rest of the clean spectrum. It's brilliant. It's such a smart way to not waste any bandwidth.
This new intelligence also changes how the network divvies up bandwidth. Okay, so with Wi-Fi 6, an access point could slice up the channel into smaller pieces, called resource units, or RUs. But each device could only get one piece. It was very rigid. Wi-Fi 7 completely changes that. Now a single device can be assigned multiple resource units. It gives the access point this incredible flexibility to basically glue together the perfect size chunk of bandwidth for every single device on the fly. It's just so much more efficient.
So you take that massive raw speed, you add this whole new layer of intelligence. What does that actually get us? What does it all mean? Well, let's tie all this tech back to those big challenges we talked about at the very beginning. This right here, this is the payoff. We are talking about latency that could actually drop below 2 milliseconds. That's incredible. It suddenly makes Wi-Fi 7 a perfect partner for 5G, especially for indoor coverage. It's going to allow for truly seamless handoffs between your Wi-Fi and cellular. And check this out. The future goal is carrier-grade 5 nines reliability. That's 99.999% uptime. This is what's going to finally open the door for those supercritical factory and IoT uses that until now you just couldn't trust to Wi-Fi.
And that leads us to one last, really interesting question to think about. For decades, right? The most demanding things you could do, I'm talking pro-level competitive gaming, high-end video editing, anything where lag is the enemy, you had to be plugged in. You were chained to that Ethernet cable. But now, with the kind of ultra-low, super reliable latency that Wi-Fi 7 is promising, could this be it? Are we finally at the point where even those last holdouts can finally and confidently cut the cord for good?